Welcome back to Black Robot. Quick question. If I give you a microcontroller and tell you to connect an LED, do you know how much current it will draw or how to make sure it doesn't burn? That's where electronic basics come in. Today we will learn about voltage, current, resistance, and Ohm's law, the ABC of electronics for embedded systems. Why electronics knowledge is essential? Let me ask. Can programming alone light an LED? Any thought? No. You need to know how much current it needs, how much voltage it can handle, and how to protect it. In embedded, GPIO pins give voltage, sensor consume current, resistors protect. Wrong design is equal to the burnt hardware. So as programmer, we must think like electronics engineer too. So it's basically electronics is the language of hardware. What is voltage? Think of it like water pressure. High voltage is equal to a strong push for electrons. It is V is equal to W by Q, which is work done divided by charge. W is here work done, Q is here charge. So in Arduino boards, 5 pin, in Arduino boards, 5 volts is the pin. In ESP32 is having 3.3 volt pin. Question for you. What will happen if you connect a 5 volt sensors to 3.3 pin? Any thought? Yes, the pin might fry because voltage exceeded safe limits. Okay. So it means over voltage damages pin. Current I. Okay. If voltage is pressure, current is flow. So I is equal to Q by T here. Okay. Q is the charge, T is time. So if LED wants 20 milliampere, a motor may need 500 milliampere. But wait, can a microcontroller pin give 500 milliampere? No, only 20 to 40 milliampere. That's why we use transistors or driver ICs for motors. Okay, always keep in mind about it. If you are using, this high voltage, you will use transistors or driver ICs for motors. So think about that. Pressure pushes, water flows. Okay, so it means pressure pushes with voltage. Water flows happens with current here. Resistance. What is resistance? Now, what if we don't want too much current? We put resistance in the way like narrowing a pipe. So it's R is equal to V by I. So it means it opposes the current here. So suppose you are having 330 ohm resistors with an LED. Okay, what will happen without the resistor there if you are having that? Yes, LED burns out because current flows uncontrolled. So basically, resistor resist the current there into the circuit if we are having the high voltage flow. So what is the relationship between I, V and R? Voltage pushes, current flows, resistance slows down. So, so they are all interconnected. That relationship is called Ohm's law. Think of it as more pressure V, more flow I, but resistance R control its Ohm's law. The golden rule for electronics is V is equal to I into R. So from this you can find current as well as resistance. So if current is there, I is equal to V by R. If resistance is there, R is equal to V by I. So this single formula is the key to shape circuit design. So for example, say if we have a 9 volt battery with 1,000 ohm resistor, okay, how much current would flow there? Very safe, a small current. So how you'll get to know? I is equal to V by R. If you're seeing here how V by R is happening, right? This is V and this is R. So V by R. This is 9 milliampere current. Very safe. So you are getting here a small current. So it means if there is a low resistance, you will get a more current and there would be the possibility of damage. What if the resistor was only 10 ohm? So it means the current would be huge, right? Because battery drains and resistance will burn it. So this is how it works. LED with resistors. Why do all LED circuits have a resistor? Any thought? Okay, so we will go for an example here. 5 volt supply is given there and LED drop is having 2 volt and current is there 20 milliampere. So resistor would become, okay, supply here we supply minus V voltage of drop which is LED one divided by I. So this is R is equal to you will get it. So you will have to use resistor of 150 ohm. Okay. So I have a question for you. What if you use 1 kilo ohm instead? Calculate it. I'm giving you time. Okay. So LED still grows, but very dim. Too much resistance blocks current because too much resistance I have given 1 kilo ohm, right? Now coming to the LED resistor, how we calculate the LED resistor there, resistance for LED. So R is equal to V supply minus V LED divided by I. So so for that 12 volt, which is the LED drop 3 volt and 20 milliampere. Okay. So resistor you will get it 450 ohm. So this is the math behind every LED series resistor you see in Arduino shields or development boards. Power in circuits. Now what about heating? Power is the reason resistor burns. So power is equal to V into I. So as example, if a resistor carries 0.1 watt but is only rated 0.125 watt, so that is safe. Okay, how you will calculate that? You will always go and you will have to see into the circuit voltage and current. You will get the power. So you will get the components rated there in wattage. Okay, how much watt you have got it. Okay, so if a resistor is carrying 0.1 watt but is only rated 0.125 watt. So that is safe. If it is carrying 0.5 watt, so that would burn because wattage is so much high, more than which we have discussed. So what is power dissipation? So power dissipation is here. So suppose you are having 9 watt across 1 kilo ohm, okay, resistor. So current you will get 9 divided by 1000, it's 9 milliampere. Power you will get 9 into 0.009. Okay, you will get 0.81 watt. Save with 1 by 4th watt resistor, it's meant 0.25 watt resistor. So I have a question for what if we used 100 ohm resistor? Okay, 100 ohm. What do we use 100 ohm resistor and current is equal to 90 milliampere. So how will get it? So power you are having 0.81 watt. Okay. So resistor burns unless it's high wattage. So this is what you are seeing. This is in originality. You will get the resistor if you are going to purchase from the market. So what is resistor? So the resistor, the simplest yet smallest component. So it limits current, divides voltage. So the traffic. Think about the traffic police. Okay, so it's a traffic police of electronics. It controls how many electrons flow. Okay, so this is what. And coming to the capacitor, capacitor stores energy and releases charge. Okay, so it stores charge and releases charge. Works like a water tank, fills and empties. Okay, so it's debouncing switch. We use it. Power supply filtering. We use it. Energy storage also we use. So that's a real time example. If you're going to purchase this capacitor, you will find. Okay, you will find in this. Uh, colors. Okay, you will get it here. You're seeing the numbers, how much capacity is given there. Okay, coming to the diode. Diode is a one way wall. So current flows only one direction. So it is used for protect circuits from wrong polarity. So it can we connect battery backward, right? No, diode blocks its board. So if you are going to purchasing market, you will get in this one. And if you are seeing there this node, okay, we'll see this one. So that's a cathode in it. Minus you need to connect here. Anode is you need to connect positive there. So it protects from the reverse of the polarity. LED is basically the light emitting diode you will get into the market with this form. Okay, so it's the same as a diode, but glows when forward biased happens. Okay, so needs resistor without it. So LED will burn it if you are not touching resistor. So here, which leg is positive? This long one is positive one, and the small one is negative one. Which means this is positive one is anode, negative one is cathode there. So this is how you can, identify the legs while adding into the breadboard or in your circuit. So what is pull up and pull down of resistors? So ever seen GPIO pins floating randomly? That's noise. So if you are pulling up, this is pull up. So it means it's a default high. If it is pulling down, it's default low. So in that case, uh, if you are using a button input with 10 kilo ohm pull up, so it ensures stable logic. It means it without it, random 0 1 is very unreliable. Okay. So that's why pull up and pull down register be basically such type of registers. If you're seeing here, so into the switch, the ground is attached, but into the pull down register with the register, ground is attached, and switch is gone above with the VCC. Okay, so and into the default high, register is added with the VCC. So current limiting registers. So if you want to protect LEDs and sensors, always use current limiting registers. Okay. So suppose you are having 330 ohm of registers and in LED circuit, so keeps current flowing 20 milliampere. So if there is no resistors, LED will die. It will burn into seconds, milliseconds. Okay. So what is voltage dividers? So voltage divider is basically two resistors splitting voltage. So it's a two resistor splitting the this voltage. Okay. So what is the formula here? If you want to calculate the V out, so R2 divide by R1 plus R2. Okay. So R1 plus R2. R2 divided by R1 plus R2 is given there. So basically, if you are having 5 volt sensor, so which is connected, MCU max is given 3.2, use divider to safely scale down the voltage there. Okay. So, so this is the trick to use everywhere in IoT boards. So, if you are going for, sometimes you are having the uh, the input voltage is 5 volt, but into the controller you need 3.3. So there you can use the voltage divider circuit, and with the switch also you can use it this kind of algorithms to just connect with to 3.3 volt on CU input. Okay, so there are many real-time examples with you. Bulb is also there. Okay, and also if you are going for the sensors, do you can use the sensor connecting with the GPIO pin, and also the buzzer also you can edit. So these are the real-time examples you can do the voltage dividing circuit. Okay, so GPIO, hello world of electronics. So okay, so MCU pin is having 3.3 volt. Okay, that resistor is having 330 ohm, so LED will connect. So MCU, what is MCU here? MCU is microcontroller unit. So it outputs voltage, resistor limits current, LEDs glows safely. Sensor interfacing. Sensor outputs 5 volt. Okay. So, but MCU pin told us only 3.2 use resistor divider. Okay. So this is the difference between working IoT project and a fry DSP32. Okay, any kind of things there. So how you use the Ohm's law in IoT boards? So IT devices run on batteries. So suppose the SP32 Wi-Fi is having 150 milliampere current it needs. So power is 3.3 into 0.15. So it's basically will take 0.495 wattage. So with the 1000 mAh battery runtime, it would be the 6.6 hours. Okay. And Ohm's law helps predict battery life, regulator heating, and safe limits. There. So what are the keys away? So keys away are we have just studied about voltage is suppose voltage is pressure, current is flow, and resistance is opposition. So Ohm's law is basically V is equal to I into R, power is equal to V into I.